good morning, everyone. How's everyone feeling after the party? Yeah, same. So welcome to the session. Now you, too, have an SDK for Jamf Pro, and it's day 3. Pretty sure you all know to use the app for Q&A, but just in case, brain's a little foggy from last night, please open up the session app and submit questions there for those in person and online. Now, it is my honor and privilege to introduce my very good friend, Bryson Tyrell.
Thanks, Kat. You really should wait until after to see if it was worth the applause. All right. Well, hello, everyone. My name is Bryson Tyrell. I am a systems development engineer at the client engineering team at Amazon. And I'm here today to talk about some code that we released into the wild that you might all be interested in and that I hounded you about in Slack for coming to see me talk about. So here we are, finally. My notes are actually really tiny on these screens, so I'm going to wing most of this presentation. Let's see how that goes. All right, so today, what are we going to be talking about? We're going to be talking about the Jamf Pro SDK for Python. This is really a deep dive session into all the things that are inside this Python package and how to use it and what it does. Big part of that, we're going to talk about configuration and credentials management. It's actually kind of a big piece of why we built this thing in the first place. Another part of that, we're going to be talking a little bit about how it handles concurrency and multi-threading under the hood. A really major feature that we actually needed badly inside our group. I'm going to go into a little bit of the advanced use cases for some of the lower level interfaces of the SDK. Talk a little bit about webhooks. So this will be the 4th JNUC now where I talk about webhooks, so strap yourselves in. And then at the very end, I'm going to talk a little bit about what's next and kind of what we want to see happen with this project going forward. All right, so first things first. Why is there an SDK? Why do we call it an SDK? Normally when you start doing something, like you don't write code for no reason. I know that's really rich hearing that come from me, but generally speaking, you don't just start writing code for no reason. The big thing when I came to Amazon is that we have a very large fleet. And some of the automation that we would run into all sorts of problems. It would take a really long time to iterate through the inventory for things that we were doing that were fleet-wide operations through the API. Sometimes we would run into token timeouts, in those operations, like, scripts were getting kind of out of control and things are time consuming. So one thing that had to get addressed was we wanted to really speed up those operations. As I mentioned, tokens expire. Tokens in Jamf Pro, there's now 2 different kinds of tokens in Jamf Pro. One expires after an hour. The other expires a lot sooner than that. As we were trying to work through all these problems and writing all this code to handle all these things for us, we were ending up with a whole bunch of copy pasta across a whole bunch of files. The natural progression of all that is, okay, well, we should probably package this and make it so that it's easy to install and port it around to all the things that we're doing. And by the time we got to that point, and we had several people on the team who were going to be using this, we kind of really had to document it because otherwise I'm the only one who actually knows how to use the thing. And I don't want to answer questions about it all the time. So, it does exist. It is a thing. It's actually been out in the wild for a month, 2 months now. You can go and install it right now on your computer by doing pip install Jamf Pro SDK, just like that. And then after you've installed it, the basic usage looks just like this. From Jamf Pro SDK, import the client, import the basic auth provider, then you can instantiate the client. I am forgetting about my transitions, so we do the import. Then we go in, we create ourselves a client object by passing in the server that we're going to be pointing at, and then the credentials provider. I'm using the basic one, providing a username, providing a password. And then, once I have the client, I can start using the built-in methods to actually start using the API. This right here is the classic API list all computers endpoint. What it actually returns is it's going to be an array of all the computers, but they're going to be objects. So they're going to be Python objects, and I can interact with those objects using dot notation like this. So it's a nice, easy interface for me to be able to interact with the data that I'm pulling from the server. So The client itself is configurable. There are a number of options that go into when you instantiate the client. Like the defaults work fine for the majority of people, but there are some settings that you can tweak in order to fine-tune the SDK to your needs. That's done through a session config object. You instantiate the config, and you can pass it in. This is effectively what the SDK does if you don't do this at all anyway. If you don't pass in the config, it just loads the default config. So we got a number of settings in here. The first two here relate to the requests that it's going to be making for you to the server. The default is that it's going to not have a timeout. So if you're doing an operation, it'll just keep waiting for that operation to complete and will never actually error if it hangs indefinitely on the server. Has anyone had that happen to them before? Yeah, you're lying. You have. So you can tweak that. The value you pass in here, number, it's going to be the number of seconds before it times out, and then an exception will get raised in the code that you have to handle, but that's where you do that. Max retries defaults to 0. This is behavior that might change in the future. It's just using the built-in retry for the requests library, which is what it uses for all the operations. But you can put that up if you wanted to actually use requests built-in retry mechanism. You can just bump that value up so that way if a request fails for some reason, it'll automatically retry. These next two values relate to the multi-threading behavior that is built into the SDK. I'm going to explore this a bit more in a few slides. All right, now these last four. Who actually is running on-prem still? Wow. Okay, good news. The SDK supports on-prem pretty well. The rest of you, if you're on Jamf Cloud, raise hands. Yeah, you don't care about this stuff, so you can stop paying attention. So, first value right there, that's certificate verification. If you need to turn off certificate verification, which you should not do, you can disable it. If you are in a specially configured environment where you need to attach a cookie to your requests because you have an extra layer of security on the load balancer that Jamf Pro sits behind, you can attach a cookie as part of your config. The CA cert bundle, if you have your own certificate like CA cert that you need to be using for requests, you can pass it in here as a file path, and then it will append it to the system trust store that it loads. So that way you have validated requests going to your server. And then lastly, the schema. You can switch it from HTTPS to HTTP, which again, you should not do unless you know what you're doing. So configuring the client itself, pretty straightforward. You can instantiate the object, and then you can start changing values, and then you can pass that in, and you could also take a dictionary and then unpack that dictionary into it. Works the same exact way. But this is how you would go about configuring the client for your code. So, authentication. This is actually kind of a big feature of it because we had a certain use case about how we handle secrets. And when I went about designing this, I wanted to make sure it was extensible because not everybody uses AWS and not everybody wants to pay for Secrets Manager. I probably shouldn't have said that, but anyway. So, the SDK comes with a number of credentials providers, and the credentials providers are built upon a base class that actually has all the logic for obtaining a refresh token or obtaining an access token and refreshing that token or getting a new token in case it did pass expiration. The credentials provider handles all of that for you. You never actually have to worry about the state of the token. The code just does it for you. The credentials providers are interfaces on top of that for how you actually give it the username, password, or now the API client ID and secret. So we got 3 different built-in ones here. Prompt for credentials is exactly as it sounds. It's good for scripts. If you don't pass a username, it'll prompt for the username, but it will also prompt for the password at the terminal. Keychain, I ripped this off of another project because it was a good idea, but hey, if you want to have the password for Jamf Pro saved on the client itself, you can just do this, load the password in from the keychain, nice and secure. And then here's our use case. We store our credentials in Secrets Manager. So this client credentials provider, you just pass in the AWS secrets ARN for where that's located. It expects it to be in a username, password, JSON format in that secret, and then it will load it, and it'll just use it for you automatically. So it's a Python package, and Python has some good features in the way it does packages so that you don't have to bloat the install if it's got a bunch of extra stuff you don't need. So the things like keychain access and the AWS component, like most people probably won't use those, so there's no need to install all that stuff in the base install. So there are a number of extra dependencies that you can do when you're installing it so that if you want to use these additional features of the SDK, you add those extra dependencies in there. If you're not using them, then you're not installing a bunch of stuff that you're not going to need. So, like I just mentioned, all those built-ins are built on top of a base class. This is an example of implementing your own credentials provider, and it was a silly idea I had where a lot of our automation all runs in AWS Lambda. Maybe all the Lambda functions that I have out there doing stuff with the API, I don't want them to actually have direct access to the credentials to actually go generate tokens. Maybe I just want them to be able to fetch tokens. So the idea here is I create a DynamoDB credentials provider, and all that it's doing is I give it a table name, and then it is fetching a cached token from the DynamoDB table. And then I have a background task running every X minutes to refresh that token and store the new token in DynamoDB. So every time these things are running, they're always going to go back out to DynamoDB when their cached token hits its expiration, and they'll always get a new one. But they never have access to the credentials. This is just an example to illustrate what the credentials provider interface is supposed to enable you to do. It enables you to handle secrets in a way that makes sense for your use case. All right, so now we're going to get into the built-in multi-threading aspects of the SDK, because one of the main things was we needed speed, because we have to iterate over a lot of records in a lot of cases. So in the first example, first slide, you saw me using list computers. There's a API endpoint in the classic API for just getting all computers, and it's like a subset of information for everything. This is a custom method that's in the SDK, where the difference is instead of calling that list computers operation just returning that, it's actually calling list computers, and then it is concurrently iterating over the entire set of IDs it got back to retrieve the full inventory records. So this is a helper method. So part of the idea of the SDK is that where it makes sense, there can be friendly curated methods that do stuff for you so you're not writing a whole bunch of boilerplate code. This method also accepts an array, so you can actually just tell it, I want these IDs, and then it will concurrently iterate over that array and fetch all of them as fast as possible. So coming back to the config, the Jamf developer documentation recommends that you don't do more than 5 concurrent operations against Jamf Pro. Reason being is they don't have rate limiting built into the product, so you have to rate limit yourself or else you might take your server down. I've done that before to a customer. So the default in here is that it will set it to max 5. If you have a beefier Jamf Pro instance like we do, you can crank that all the way up to absurd levels like 20 or 30, assuming that you're also on a system with a fast enough CPU, because Python is still, it can only run on one core, so you can't actually, make use of multiprocessing, and I did not want to write multiprocessing code. But you can tweak this value, and you can crank it up, crank it down. Like if you want to actually enforce no concurrency no matter what you're doing, just set it to 1. And, see what works best for you. So returned exceptions controls behavior for when it hits an error. So especially if you're trying to get individual computer records, sometimes, who's ever had a Phantom 409 error trying to read a computer record? Hey, Tony, over there, yeah. And that was probably because there was a duplicate serial number in the system, and Jamf Pro got really confused and just said, hey, I don't actually know what you're asking for. So if you're trying to fetch 2,000 computer records and then it bombs out on you, you don't necessarily want it to error out. Maybe you can figure out what you missed down the road, or maybe you just want to see the error that happened. So the concurrency operations in the SDK, they will capture those errors. They won't stop the whole operation. And you can say whether or not you want the returned object to be the exception that happened, or just to skip over it silently and not return that exception. You'll figure it out later. So that controls that behavior. So this example here is to kind of demonstrate the benefits that we get out of writing code this way, or not having to write code this way because we already wrote it once. This top one, this is pretty much the same exact internal logic as the getComputers method. It's going to call list computers, and then it's going to get every single computer, except the top one does it serially. It's just one after the other. It won't do it with concurrency. The bottom one uses the built-in concurrency handler, so who wants to guess what the speed difference between these two is?
4 times faster.
Close. 14 seconds for the top one, 3 seconds for the bottom one. And that was using the default setting of 5. So if you have to iterate over computer records in a way where you have to use like the individual endpoints for them, you can actually achieve great speed gains by wrapping them in concurrent operations. All right, so I've talked a lot about the classic API so far because I think a lot of us are still using the classic API. There's still functionality in there that we need, but the Pro API has come a really long way. And another goal, as we got deeper into the SDK, was to make sure there was a really good programmatic interface for the Pro API because probably this time next year we're not going to be using the classic API anymore. I'm not taking any bets, don't try me. But, so, pagination. Has anyone actually used the Pro API and played with the pagination options for trying to get through it? Did you have a good time with it? So, not a lot of fans, but this right here is calling the Pro API's computer inventory get, so that's a paginated endpoint, right? What's missing from here? You don't see any pagination options. Why is that? So, this is the low-level interface in the SDK that automatically handles all pagination for you. That top-level method actually paginated across all the results in Jamf Pro without you having to do anything. Paginator, do I have transitions for this? I do. So, actually no, I have one transition. So, paginator, this is pretty much what it looks like for that getComputer inventory endpoint. I just filled in what the defaults are. It uses the Pro API client that gets passed in. There's the resource path that it's calling without /API in front of it. The return model, so like you saw in all the other operations, when you perform a read request, it's going to return a model so that you can interact with it, or you can just dump that to a dictionary if you prefer to work with the dictionary. You can specify the start page, the end page. Oh, this is old code. There's an end page option, so you can specify the range of pages you want now. You can set the page size, which is limited to 2,000. That is not in Jamf's documentation, but that is the limit, I checked. And then we have options for the sort expressions, the filter expressions. The extra params right there, that's for any of the APIs where they have things like sections, like in the computer and mobile inventory get operations. Like that's where it passes it in. Those become query string parameters on the request. So the sort and the filter expressions, who's used those? Do you like writing those strings? You did it once. Well, it was easy. Did you do anything complex, though? So Jamf Pro, the paginated endpoints for Jamf Pro support sorting by fields, and you can do multiple fields. So like, the leftmost field will be what sorts by first, and then it'll sort those results by the second one, and so on and so forth. And then you have filter expressions, or filters, or filter strings, where you can say, I want only the records that have this field matching the operator for this value. So like less than, greater than, equal to, in an array, whatever. So we wanted to provide a much more Pythonic interface for actually working with those things, because you don't necessarily want to have to always be hand typing out RSQL strings. So, right here, I'm importing the filter field and the sort field options. Filter field, call it, tell it the field name that I want, and then the comparison option is a method that's on it. I call that. It returns a filter expression, and that filter expression will generate the string that I need that I can pass into the paginator. Same thing for sort fields. It has just the ascending and descending options, and that will produce the correct string when you pass it into the paginator. So for doing much more complex options, again, wanting kind of a more Pythonic interface, filters support the and or binary operands, so the ampersand and then the pipe symbol. You can just chain them together exactly like this, and then they will form a final filter expression that will generate the complex filter string that you actually wanted. The grouping options, where it's going to be a set of parentheses around a set of filters, so that way those have to evaluate, those all evaluate ultimately true or false and then get compared with the other ones. You can just use the filter group function to wrap those, and then that also supports the and or operands in order to combine them with other filter groups or filter fields. So you get this nice little interface that's in code, so you get code completion if you're in your IDE or editor, and it'll do the work for you. Sort expressions, pretty much the same thing. They only support the and operand because that's the way that the expression language works. But the leftmost one will be the first, and then the right, and then so on and so forth down the line. And if we wrap that all together, this is what a complete interaction with the SDK to do a paginated request over the Pro API would look like. Importing all the stuff, creating the client, saying which sections from the inventory I want, setting the page size to is that 1,000 or 100? It's 100, cool. Oh no, it's 1,000. And then sorting by the ID ascending, and then putting in a filter field for operating system version less than 13. These built-in methods that we add to the SDK also will throw errors if you pass in a field value that is not supported by that API. So like if you just pick a value out of the computer response, you say I want to filter by this, but it's not actually in like the supported list of fields, you'll get an error for it and you'll know exactly what went wrong. All right, so we're going to talk a little bit about the lower level interfaces that all these things are built on top of, because not every single API will probably be supported in the SDK as a curated method. Most of them probably don't have to be. And also, Jamf is constantly, iterating on the API as they release new versions of Jamf Pro. So like, you might be testing the beta, and there might be stuff that's in the beta that's not in the SDK yet. So you still want to use them. Well, you can actually just go through and you can just use one of the lower level interfaces directly, and you can still leverage all the internals of the SDK and not have to worry about it. So, classic API request right here. This is what the interface looks like. The data option accepts either a string or it will accept a classic API model. And the models behave a little bit specially inside the SDK for the classic API because it's an XML-based API when you're writing to it, right? But all the responses, we're doing JSON for the returns with the understanding that sometimes the JSON deviates from the XML. We'll see how that shakes out. Maybe we change this. We'll get to that later. You put in the path up there that you want without including JSS resource. If you need to override any headers, you can do that here. The interface for the classic computer model, what it does for you is it contains a built-in method to actually generate an XML string. So if you don't want to work with Python's existing libraries for generating XML, you can leverage the model. You just create what you're going to do as a dictionary, and then you pass that into the model, and you can call the XML method, and it'll generate the XML string for you. Or you don't have to actually generate the XML string first unless you're like testing and validating. You can just pass the model in, and the method will take care of the XML conversion for you. There we go. All right, Pro API. Pro API is a lot simpler because it's JSON in, JSON out, and it's a lot easier, especially since Python dictionary objects translate almost one-to-one with JSON. So same thing going on here. Pass in the method you want. We get patch with the Pro API, which is cool. Don't include API for the base path. Just put in the rest of the path that you want to actually call to. You can pass additional query params on this one. The data can be either a dictionary or any Pydantic model. You can use the built-in models in the SDK, or you can just create your own if you want to. It just works. And then, again, same option for overriding headers. So the concurrent API requests method, this is built into the SDK. This is available for you to use. It's really just a wrapper around concurrent futures thread pool executor. I remembered that without looking at my notes. So it's not really hard to use that, but this is a nice wrapper. This is what the SDK uses internally in order to wrap all of its concurrent operations. It's available for you to use. Once again, going through the classic API example where it's that get computers method, this is kind of what it's doing under the hood. You put in the handler for what you want it to call across all the threads that it's going to spin up. And then in arguments, you give it an array of all the values that are going to get passed in. So like the array is what it iterates over. And it's like this one is going to be for thread 1, this one's going to be for thread 2, so on and so forth. If it's a simple array, like 1, 2, because maybe the function only takes a single argument for ID, so like you just need to provide the ID, you can do a simple array and it'll just pass that value in for that. If it takes multiple arguments, pass in dictionaries for the array, and then it'll unpack those and pass them in when it calls the function. And then you have some extra controls here so that you can say whether or not you want to return a model, or maybe you just wanted to return a dictionary response. You can override the max concurrency here with the caveat that you can't set a value higher than what you configured for the session object. And then finally, the return exceptions, you can again control that behavior here and override whatever you have inside the config. Oh, and one thing I forgot to mention for that is if you want to actually do multiple API operations in sequence and do that across multi-threading, just write your own function that calls all of those and then pass it in as the handler that you want to call for the concurrent operations. The token refreshing that happens on the concurrency stuff, it's thread safe. So what happens is if you have a long-running operation and there's like, 10 threads running, all doing stuff against the API, and all of a sudden your token expires, you've got 10 threads that are all going to go and try to refresh the token at the same time, right? But there's a thread lock, so what happens is the first one that gets in there locks it, all the others are then waiting. So it'll only refresh the token once, cache that token, return it to the thread that got in first, and then all the others are allowed to go through and they all get the cached token. So you don't have to worry about multi-thread operations spamming for new tokens, and I don't think there's any penalty for that nowadays, but it's not really efficient, so it'll just handle it nicely. The paginator, we saw this a little bit already, but if you're using the paginator directly, the behavior changes slightly because you're not iterating over all of the results. You're going to be iterating over pages. So when you instantiate a paginator, you get an object. The object itself is callable, and what the paginator does is it will go to the API that you requested and perform the first request. Then, based on the response and the parameters that you had passed in, it will see whether or not, okay, the total number of items is this, the page number is this, like the amount per page is this, how many pages are remaining? It then figures that out, and if there's more than one page remaining, it'll then spin up a concurrent handler under the hood, and it'll just fetch all of those all at once, and then recombine the results for you in the end. So, concurrency under the hood, in some cases, depending upon the resources of Jamf Pro and the resources of your client, setting a lower page number than the full 2000 can sometimes be faster because it's fetching all the remaining pages concurrently. But when you're going over it, you actually are interacting with a page object, and the page object will tell you which page number it was, what the page count was, what the total was, and then the results. All right, now we're getting to the section where I get to do a little spiel on webhooks again. So I've talked about them, at 3 JNUCs in the past, back when I was at Jamf. Webhooks are really powerful for enabling event-driven automations because, you can react near real time to things that are happening in the server, and then you can act on those. You don't have to be polling the API constantly trying to figure out what changed. Very powerful. But they've also lacked kind of developer support or even testing support, right? There's no try me button inside Jamf Pro. So you don't have the ability to, like if you're trying to build a webhook receiver or something to receive webhooks, with some custom code, you don't have a way of actually validating the webhooks. Like, you're kind of on your own a little bit when it comes to that. But I do, and yeah, there's very few developer tools for it. I do want to shout out the people at Pixar and JNUC because that's a Ruby framework, and they did solve that problem. But we don't really have anything for Python, except in the SDK, there is a client for you to actually have a webhook simulator. So that is also another extra install. Again, if you're using the SDK and you're not doing anything with webhooks or testing, you don't need all the extra dependencies that this brings along for the ride. So pass in the webhooks extra, and then you can get what you need in order to actually use the webhooks client. The way this works is we have all of the webhooks as models inside the SDK. Those work without the extra dependency installs, and we'll talk about that in a second. But the webhook generator will actually take those models, and then it'll give you back something that will allow you to create unique webhook payloads that you can then test with. It's all just random data generation, but it'll generate realistic looking data. Like this is an example for computer added. You can see here that it's generating an actual timestamp. You got an ID, you've got realistic looking MAC and IP addresses and serial numbers and UDIDs. So like it's got enough real data that you're actually able to sort of like mock the experience and test whatever it is you're building. To use these, you're going to import the webhooks client, which is a completely separate client because it doesn't actually touch any of the Jamf APIs. You instantiate the client, you pass the URL of whatever you're going to send test event data to. So if you're doing this, if you're like building something locally and you want to test locally, it's going to be off of localhost probably. Then, kind of like in the last slide, you're going to generate a mock data event. This one is for computer check-in. So you use the generator, you get a webhook generator, you call the build argument to create that unique event, and you can use the client's send webhook command to just send off one instance of it. This is good if you want to generate an event and then you want to retest that same event multiple times because you're fixing behavior. You don't want to like have random data across them and you're just trying to work with one. The other option is you can pound whatever it is that you're building and hammer it with as many events as you want. If you pass in the model, it'll actually then go over whatever you pass for the count. It'll send, in this example, 10,000 events to your webhook receiver for testing, and every one of those 10,000 events will be unique. So great way to do a little bit of stress testing, but also with seeing if your system actually is respecting the random data nature and the differences between those events. So on the subject of like trying to support more easily building your own automation, again, you can use the models in the SDK as a part of trying to build a webhook receiver. Fast API is a really, really great Python web framework. It's similar to Flask in a lot of ways, but it's built on top of Pydantic in some respects. So those models, which all the SDK models are Pydantic models, you can bring those in and you can use those for, I don't have a box for that. You can use those for the endpoint that takes it, and you can actually say like they have to match these schemas. So you can actually have schema validation on incoming events using the SDK's models, and then you can reject any events that you don't support right there at the API level. And then when you do get it, you can actually interact with the webhook events using dot notation like the rest of the SDK, because that's how Fast API passes them in. Nice little helper. Maybe there's more that we can do here to make the webhook piece even more powerful and streamline it a bit. That's open for discussion. And there is one more thing, because I was allowed to change my slides a little bit before JNUC. Don't get mad, but there was an announcement. They added some stuff to the Jamf Pro API. There was a session about it here at JNUC. There is a JCDS2 client built into the SDK. Fantastic. Oh, okay, see, that might have warranted the applause from the beginning. It took this long. So, SDK client built into this. The SDK client is kind of interesting because on its own, it handles some of the file operations, but it's really chaining together the classic and Pro API requests that are required to do these upload-download interactions for you. And it has a few other tricks up its sleeve. So, JCDS2, so we had the Pro API client, the Classic API client, and now we have the JCDS2 client right here. Upload file, you just pass it the path to the file that you want, and then it's going to, this is all in my notes. My notes are all really tiny, so I'm going to do my best here to do it from memory. There's a page in the documentation about the nuances of this, and this is, again, is open to change based on feedback. When you go to upload a file, first thing it's going to do is it's going to iterate all of the package objects that you have in Jamf Pro to see if that file name exists anywhere, because if you run a multi-distribution environment where, yeah, you have Jamf Cloud, but you also have other file servers in the mix, that file might exist and might not exist in the JCDS, so it's going to skip over it. Again, come see me afterwards if you have feedback about this or you try it out, and this is behavior I think we can change. This was a quick first pass at it. What it's going to do then, after it checks all the packages to make sure the file doesn't exist and checks the JCDS to make sure the file doesn't exist, it's then going to perform the Pro API request in order to create the file object, get back the temporary S3 credentials, and then it's going to use those credentials and it's going to perform a multi-part upload to S3. Well, that's actually conditional. If your file is less than 1 gig, it's just going to do a single upload, and it's just going to stream it up there. If your file is larger than 1 gig, it will break it out and actually perform a concurrent multi-part upload request. It'll do it in 20 megabyte chunks across 5 threads. And what that's going to net us is, it doesn't do it today, but what it's going to net us is the ability so that if you have a blip as you're trying to upload something and you have a few 20 meg chunks failing, we're going to add retry logic into that handler, so that way, if you're 2 gigs into a 5 gig upload, you don't have to restart the upload, and it will gracefully recover as it retries those chunks. Pretty cool. And then after it successfully uploads the file, it will then create the package object using the Classic API, because that's not in the Pro API yet, and you're ready to go. The download file works kind of the same way. Instead of just doing a single file download operation, it will actually chunk it out, do it in 20 megabyte chunks, and then reconstitute the file afterwards. And again, that's so a little later, go back in, add in retry logic so that if there's an interruption while attempting to download the file, it will be able to just restart those 20 megabyte chunks and then still successfully complete. The one thing that's not in there yet is hashing the file locally on the system to ensure it matches, but that'll get added in later. This is a quick first draft, and very much open to feedback, especially since not all of us can yet play with the JCDS2. So, the last point from the beginning of the presentation was that we needed documentation for all of this. And I'm happy to say that it's probably one of the best features of the SDK. I was remiss to not really mention this too much up front when we talked about installing it, but this project was released under the MacAdmins open source organization. It's on their GitHub. It is now part of the MacAdmins open source project, and the idea is that we want it to be owned by the community going forward, and the community can help shape it. The documentation gets published to GitHub pages, and it looks pretty good. The docs feel good. Most of what you saw in the presentation here is actually detailed as user guides in the documentation. So you can come here and you can start exploring around and get a better understanding for how this project works. There's the getting starting guide, for how to, quickly jump in, install it from using pip, and, starting to import things. There's full references for all the components of the SDK in here. So if you want to get into what are all the methods and all the other operations, they're here. The way that I like to do documentation is that all of the how-to is human written, and it links back to references so that you can then go explore the classes from the documentation as you're going through the guides. But you can still explore everything just like this, you're probably familiar with other Python projects. A lot of what you saw in that little webhook section that we did in this, that's actually pulled directly from the documentation. So webhooks has their own section for you to explore and better understand how to use these features. And then another late addition is that the contributor documentation is now up on there. And I'm going to touch on that in just a second. So that is pretty much the deep dive into the SDK and how to use it. So now that it's out there, what now? It's in an alpha. And the reason we're calling it an alpha is because we wrote the things that we needed for our use cases and not necessarily yours. So it works really great for us. Labeling an alpha means that if we need to introduce breaking changes because the consensus on feedback is that the interface doesn't quite work for everyone, it's okay to break things in an alpha. It's not okay to break things after you release a project and call it stable. So a big part of this, starting today, if you want to start using this, is feedback. What's missing that you need? What is there that you don't think is quite right? And what would you maybe want to see changed? And on the main GitHub README, there's a section that actually discusses the types of feedback. You know, if you hit a bug, there's a bug issue template. If you want to propose a change, there's a feedback template, and that's to start a discussion about the change that you're proposing. And then finally, feature requests are treated a little bit differently. Feature requests are you actually have something that you want to see added. It doesn't necessarily change anything, but like it's missing. You'd like to see it added, and you're at the graces of the rest of us who are maintainers to actually get it in there. But you could also be a contributor. So the documentation page that you saw for contributors, that has a full outline for what the expectations are if you want to make code contributions to the project. There are no gotchas in there. It's very clear about elements of how you do documentation, how the code formatting works, which the code formatting is not bespoke. It actually uses two tools that get installed in the developer environment to format your code, and there's a command to format your code for you. So there are no opinions. We've given up all of our opinions and let the tools just do it for us. And then on all these things, there are two places in Slack, the Mac admin Slack, to go and actually talk about them. If you are a user of the SDK and you are discussing usage of it, go to the Jamf API channel. If you are going to be a contributor to the SDK and you want to discuss your code contributions or the changes that you've opened up issues for, come to the Mac admin's open source channel. And that's where those conversations will take place. And with that, we've got 3 minutes. So thank you for coming to watch 50 slides of code and me talking about it. And now go build stuff.
All right, thank you, Bryson. We have a few questions we'll try to get through as fast as we can. First one, can this be used with standard Linux distributions?
I don't see why not.
Okay.
I mean, the keychain extra won't work on Linux, but we could always plug in a credentials provider that does work for how Linux handles local secrets. So again, back to the contributors part. If you want to see additional credentials provider interfaces that are just built-ins because they'd be useful for a lot of people, there are pull request guidelines.
All right. Do you support the Jamf cookies to hit the same cloud endpoint for iterated requests?
So it's using requests under the hood. So when requests is going out and making calls, it's using a session object. So the session is storing the cookie. So that should just work. If it doesn't, open a bug report.
All right. Does JCDS2 allow download file to specify the package by Jamf ID?
No, but there's no reason we couldn't do that. Open the feedback form or feature request.
With the webhook client, can I set a delay between iterations?
No, but that's a good idea. Open the feature request. Y'all see where this is going?
As it is updated and APIs change, will there be a version selector or easy to download repo to get a compatible version that matches the Jamf Pro server version for us on-prem folks?
That is a really great one. I have actually thought about that. So here's what I'm going to say. Open a feedback issue so that we can start the discussion about that, because I've thought about it. I don't know the best way to implement that, and I would like some opinions on how to implement that, because stating minimum or maximum version for the SDK, we're going to have to add attributes to the built, or checks to the built-in methods so that it sees whether or not the client is at the correct version. And then we also have to know which versions those APIs were introduced, when they were deprecated, and But like hand in hand with that, there aren't deprecation warnings in here yet. And one of the things is like I want to implement the warnings module from Python, so that way when Jamf deprecates something and you're on a version that's past the deprecation point, we would want to log out a warning saying this is a deprecated feature. So like open up one of the feedback issues so we can start that discussion, because I don't want to just make the decision on how that looks. I'd rather hear from people how they would want it to interact, how it would work.
All right, last one. What's the minimum Python version required?
3.9. So I didn't go too low. I didn't go too low on this one because y'all shouldn't be using things older than 3.9. Come on, we're on 3.10 now, 3.11 now. But at the same time, I didn't want to do anything newer than 3.9, even though there's a lot of really great stuff I had to give up in 3.10. The part of the developer guidelines, when you're adding code to it, you must type hint everything, because it makes our lives easier when we're using the SDK in code editors like PyCharm or VS Code. Like, it'll give you hints about, like, this is the type of the value that's accepted when you're trying to pass an argument. Type hinting is way better in 3.10 than it is in 3.9, but we're not all there yet, so 3.9 is the minimum. It should just work with any newer version of 3 afterwards.
Awesome. Thank you, Bryson.